In this example, we want to graph the equation 4y squared minus 9x squared plus 16y minus 18x plus 43 is equal to 0. This is the equation of a hyperbola, and before we start graphing, we have to write it in the standard form. The standard form offers a lot of information about the hyperbola itself, like the coordinates of the center or the values of a square and b square that we use in the graphing process. So the first step in writing this equation in the standard form is to group the x and y terms together. We'll start with the y terms here. This is y group. Now we'll group the x terms, negative x squared minus 18x, and we subtract 43 from both sides, so we'll have negative 43 on the right hand side. From the group of y squared, we'll factor out 4, so we'll have y squared plus 4y, and then we'll leave the place to complete the square. From the group of x's, we'll factor out negative 9, and we'll have x squared plus 2x, and then we'll leave the place for the special number that will complete the square, and we'll have negative 43, and then we'll add 4 times the number we add in the first group minus 9 times the number we add in the second group. The number that will complete the square of the y's is 4. The number that completes the square of the x group is 1. And therefore, what we get is equation now 4, y plus 2 squared minus 9 x plus 1 squared, and the numbers on the right hand side add up to negative 36. We divide every term by negative 36 to get 1 on the right hand side, and we'll have y plus 2 squared over negative 9, so let me put the minus in front, plus x plus 1 squared over 4 is equal 1. We can rewrite this equation so it looks like a standard equation of a hyperbola that we are accustomed to. We'll put the minus sign, the term with the minus sign, as a second. And we have the standard equation of a hyperbola. The equation allows us to read the center from the form. The center of that hyperbola is at the point negative 1, negative 2. The minus sign is in front of the y term, so this tells us that the vertices are on the line that is parallel to the x-axis, and this also tells us that the value of a squared is under x expression, so this is 4, and the value of b squared is under y, so this is 9. So b is equal 3 and a is equal 2. So let's plot the center. Center is at the point negative 1, negative 2. And now we'll use value of a to find the vertices. The value of a is the distance between a center and a vertex. And we know vertices are on the line that is parallel to the x-axis. Then starting with the center, we'll go 2 units to the right to find the vertex, let's say v sub 1, and we go 2 units to the left to find the vertex v sub 2. Now we'll use the value of b to find the points that we'll use to graph the asymptotes. So starting with the center, we go 3 units, or the distance of b, to find one of those points, and 3 units down to find the other point. Now we'll use the rectangle. We draw the rectangle going through those 4 points with the sides parallel to the x and y axis, and we'll draw the asymptotes. So the asymptotes are through the diagonals of that rectangle. So this is the one asymptote, and we'll have another asymptote going through the other diagonal. Once we have the asymptotes, we are ready to draw the hyperbola. Start with the vertex and go in the direction of the asymptote and to the bottom as well. And we'll repeat this on the other side, starting with the vertex, go toward the asymptotes to the top and to the bottom.